Yeah. All right, today's lesson is solving problems about proportional relationships. We'll be solving problems today with a focus on asking questions about a situation to get information that you need and possibly even to determine whether or not the relationship is a proportional relationship. Consider the problem. A person is running a distance race at a constant rate. What time will they finish the race? What information would you need to be able to solve the problem? So at this point, I'm not asking you to solve the problem yet because you don't have the information you need. I want you to think about what you might need to know in order to get the information to solve the problem. So pause the video, jot down a list of things that you might need to know to solve this problem, and then come back and check to see what kinds of things you might ask. All right, I hope you jotted down your own list of questions. One question I would have is, how long is the race? So I'm going to tell you how long the race is. The race is 10,000 meters long. Okay, if I'm going to be able to tell what time the person is going to finish the race, what time did the person start? So I'm going to tell you the person started at 9:15 a.m. I also might want to know, well, how fast did the person run? So I'm going to give you some information about that. I'm going to give it to you a bunch of different ways, and you can decide what you might use. In 1 minute, whoops, spelled minute wrong there. Let's try this again. In 1 minute, the person ran 156 and 1/4 meters. I'm also going to tell you another way. I'm going to say it takes the person 32 minutes to run 5,000 meters. And I'm going to tell you another way. I'm going to say the pace is 6.4 minutes per kilometer. I'm also going to go a step further. I'm even going to give you, no, maybe I won't give you that. I was going to give you an equation you could use, but I don't think I'll give that to you. I'll let you figure out the equation. All right, so what I would like you to do now, you now have the information that you need to solve the problem. You may not use all of it, but there's a bunch of different pieces of information for you to choose from. So I want you to pause the video, attempt to solve the problem, and then come back and look at how I did it, which may or may not be the same as the way you did it. So there's more than one right way to do this problem, but there only is one right answer, only one right time. So you can come back to compare to see if your time is the same as my time. All right, so when I'm looking at the information that I need, I know that I'm definitely going to need to know that it started at 9:15 a.m. And there's only one piece of information that gives me the length, and it gives me the length in meters. So when I am picking which one of the remaining three I'm going to use to represent my rate, I'm going to pick this one. The reason I'm going to pick this one, first of all, is because it gives the distance in meters. So this one also gives the distance in meters, so that would probably be my second choice. This one is talking about kilometers, and I really don't want to switch meters to kilometers, and I don't even know if it would be useful to do that. So I'm going to go with this one. I also like this one because it says in 1 minute. So it's giving me a unit rate. It's giving me the constant of proportionality for this problem. So if it's 156 and 1/4 meters in 1 minute, 156 and 1/4 is our constant of proportionality. And that constant of proportionality, let's just say the COP, represents 156 and 1/4 meters per minute. Okay, now the next thing I'm going to do is I'm going to write an equation because I feel like that would make it a little easier for me to solve this. So I'm going to write an equation that represents the relationship between distance and time. So I'm going to say let d equal the distance. So the letter D is going to stand for the distance, and I'm going to specify the units I'm going to use. It'll be the distance in meters. And then I'm going to let T equal the time, and since I'm talking about minutes here, my unit is going to be minutes. So if the person runs 156¼ meters per minute, then I can multiply this times the number of minutes to find how far the person ran. So I can say the distance would equal 156¼ times the time. So now I have my equation. Now I'm going to need to solve this. So if I look at the other piece of information that was given to me, well, I have two more. I know what time he started, but that's different. That's not the T I'm looking for here. That's the time in minutes it takes to run the race. That's not what, or T represents the time in minutes, and that's not what this tells me. This just gives me a starting time. So I'm not going to use that yet. I'm going to use this information, that the race is 10,000 meters long. That's the distance. That could go in the place of D in my equation. So I'm going to rewrite this equation, and I'm going to put 10,000 in the place of D. I think I'm also going to change this fraction to a decimal, just because I'm probably going to want to do this on the calculator, and I'm not going to want to use 1/4. So I know that 1/4 is the same as 25 hundredths. So I'm going to change that to 156⁻² times T. Now to find what T is, I'm going to need to divide 10,000 by 156.25. So I am going to use my calculator to do that. So 10,000 divided by 156.25 is 64. So I know that my time, I'm going to need to move over here, my time is 64 minutes. So it takes the person 64 minutes to run the race. Now I'm going to go back, I'm going to look, well, okay, the person started at 9:15 a.m. 64 minutes would be 1 hour and 4 minutes. So that would also equal 1 hour and 4 minutes. So if I go from 9:15 to 10:15, that takes up the hour. If I add another 4 minutes, 15 plus 4 is 19. So the person would end the race at 10:19 a.m. So even if you did the problem differently, hopefully you ended up with that answer. If you didn't and you're a little confused, you might want to try watching this part of the video again. Sometimes it's helpful to see something more than once. All right, if you were in class, you would now be doing this activity. It's called an info gap, biking and rain. So how this works is, if you were in class, I would give you either a problem card or a data card. So you would get a problem card and your friend would get a data card, and you're not supposed to show one another your cards. So here's what happens. If you get the problem card, which is what you're going to get right now, so you're going to silently read the card and you're going to think about what information you need to answer the question. You can only ask your partner for the specific information that you need, and if the information is on your partner's card, your partner can give it to you. You need to explain to your partner how you are using the information to solve the problem, and then you need to solve it and explain your reasoning to your partner. So we're going to do 2 examples together in this video. This just tells what happens if you get the data card. Since you're watching the video, that won't apply to you. All right, so the first card says, May and Noah each leave their houses at the same time and ride their bikes to the park. For each person, write an equation that relates the distance they travel and the time, and then answer the question, who will arrive at the park first? So this would be a good time to pause the video, think about what information you might need to solve this problem. All right, I hope you took some time to think about the information you would need. I'm going to go ahead and give you a bunch of information since you can't ask me questions since you're just watching the video. So, if you had problem card 1, your partner would have data card 1, which will give you the following information. Noah lives 1 kilometer farther away from the park than May does. May lives 8,000 meters from the park. Noah lives 9,000 meters from the park. May and Noah each bike at a constant speed. May bikes 250 meters per minute, and Noah bikes 300 meters per minute. So this is fairly important that it says May and Noah each bike at a constant speed. That might not have been something you thought to ask because you might have assumed, but it didn't tell us in the problem that they're riding at a constant speed. So that would be something that you might want to ask. Well, are they riding at a constant speed? Now, for each person, we're going to write an equation that relates the distance they travel and the time. So I would encourage you to pause the video and see if you can write an equation relating distance and time. You might write your equation slightly different than I write mine, but go ahead and give it a try and then come back and check it with me. Okay, so I am going to pick some variables here. I'm going to let the letter D be the distance, and I think I'm going to go with meters because it looks like most of my information is dealing with meters. So I'm going to say D is going to stand for the distance in meters. And then I'm going to use the letter T. That's always a good one for time. I'm going to use the letter T to represent the time, and let's see what I have over here. I have minutes mentioned over here a couple times, so I'm going to say T will be the time in minutes. So I'm going to write an equation, and I'm going to start with D. I'm going to say that D equals something times T. And you might choose to do T equals something times D, but here's why I started with D. If I look at my rates over here, I know that May bikes 250 meters per minute. So that means I'm going to need to multiply the 250 times the number of minutes. So that's why I chose to put time here, so I would be multiplying times the number of minutes. So first let's write an equation for May. So May bikes 250 meters per minute. So May's equation would be the distance would equal 250 times the number of minutes. Noah, on the other hand, Noah bikes 300 meters per minute. So his equation is going to say that the distance is 300 times the number of minutes. Now, I'm going to need, if I want to know who's going to get there first, I need to know how long it's going to take each of them. So it doesn't tell me that on the data card, but it does tell me that May lives 8,000 meters from the park. So that's the distance that she's going to have to travel. So I'm going to go down to May's equation, and I'm going to say, okay, May's distance is 8,000 meters. So I'm going to say 8,000 equals 250 times T. Now I'm not going to multiply these two numbers to find out what T is. I'm going to have to divide. So I'm going to do 8,000 divided by 250, and I get 32. So it's going to take May 32 minutes to ride her bike to the park. Noah, let me take a look up here for his distance. Noah lives 9,000 meters from the park. So in his equation, I'm going to put 9,000 in for the distance. And again, I'm not going to multiply these numbers. They're not on the same side of the equal sign. I'm going to need to divide to figure out what I multiply 300 by to get 9,000. So when I do 9,000 divided by 300, I get 30. So Noah's time was 30 minutes. So since Noah took less time to get there than May, Noah will arrive first. Okay, let's take a look at another question. If you had trouble solving this one on your own, you might want to try the next one because it might be a little easier since we've tried one. Okay, problem card 2 says, A slow, steady rainstorm lasted all day. The rain was falling at a constant rate. Write an equation that relates how much rain has fallen and how long it has been raining. And then, how long will it take for 5 centimeters of rain to fall? So, think about some questions that you might ask, information that you might need to solve this problem. Okay, I hope you maybe paused the video, took some time to think about that. Let's look now at some information that goes with this problem. The rainstorm lasted for 24 hours. Well, that makes sense, right? Because it said it rained all day. 9.6 centimeters of rain fell during the storm. The rate of the rainfall was 2 millimeters of rain every 30 minutes. There are 10 millimeters in 1 centimeter. There are 60 minutes in 1 hour. Okay, so that's useful to have some of that conversion information there. So we're going to write an equation that relates two things: how much rain has fallen and how long it has been raining. So I think I'm going to use R. I'm going to say that R will be how much rain and let's see, what do I want to use? I need to pick a unit. It's like, how am I going to measure the rain? Well, it says, how long will it take for 5 centimeters of rain to fall? So I might find this in centimeters, the amount of rain in centimeters. And then I need to know how long it has been raining. So I like to use T for any kind of time, represent the time in, let's see what I should use for my units for time. So I have some things here. I have the rate being 2 millimeters of rain every 30 minutes. And then I have the time. I have here that it lasted for 24 hours. And it's telling me that there's 60 minutes in an hour. So I'm not sure. I think I'm going to do time in hours. I probably could choose to do time in minutes as well and then maybe convert to hours later, but I'm just going to go with time in hours because I think it's going to take a pretty long time for this rain to fall. Okay, so let's write an equation first. So my equation is going to be based on one of my rates here, and it says the rate of the rainfall was 2 millimeters of rain every 30 minutes. Okay, well, that doesn't really fit. I want to do how much rain in centimeters, and I want to do how much time in hours. So let me just say 2 millimeters, whoops, a couple extra M's there, 2 millimeters every 30 minutes. Well, I know that there's 10 millimeters in 1 centimeter. So if there's 10 millimeters in 1 centimeter, I'm going to need to divide 2 by 10 to figure out how many centimeters that would be. So if I divide 2 by 10, I can just move my decimal over one place, and I get 2/10 of a centimeter every 30 minutes. This is stating the same thing. 2 millimeters is the same amount as 2/10 of a centimeter. Now, I want to know how much rain is going to fall in 1 hour, because that'll give me a unit rate. So I'm going to say, how many centimeters every 1 hour? Well, an hour is twice as long as 30 minutes. So if I double 2/10 of a centimeter, I get 4/10 of a centimeter. So the rain is falling at the rate of 4/10 of a centimeter every hour. So I'm going to need to multiply, since it's falling this many centimeters every hour, I'm going to multiply that amount times the time to get the total rainfall. So that would be my equation. Now, the question is asking me, how long will it take for 5 centimeters of rain to fall? So 5 centimeters, that's not T, that's not the time, that's how much rain has fallen, or how much rain we want to figure out is going to fall. So 5 equals 0.4 times T. In order to find what I multiply 4/10 by to get 5, I need to divide. So I'm going to do 5 divided by 4/10. So if I didn't have a calculator handy, I could do 5 divided by, I could do it this way, divided by 4/10. I know you guys love fractions, which would be the same as 5 times 10 over 4, which would give me 50/4. And as a mixed number, that would work out to be 12.5. So T equals 12.5 hours. Again, you might have done the problem a little bit differently. Your equation might even have been different depending on how you defined your variables. So maybe you said that T was the time in minutes, and if you did, your equation would be a little different. But the important thing is that you ended up with an answer of 12.5 hours. All right, this next part, moderating comments, we would be doing together in class. Let's read it together. A company is hiring people to read through all the comments posted on their website to make sure they are appropriate. 4 people applied for the job and were given 1 day to show how quickly they could check comments. Person 1 worked for 210 minutes and checked a total of 50,000 comments. Person 2 worked for 200 minutes and checked 1,325 comments every 5 minutes. Person 3 worked for 120 minutes at a rate represented by C equals 331T, where C is the number of comments checked and T is the time in minutes. Person 4 worked for 150 minutes at a rate represented by T equals 3/800ths C. And we're assuming that C, again, represents the number of comments checked, and T is the time in minutes, just like for person 3. So number 1 asks us to order the people from greatest to least in terms of total number of comments checked. Okay, so let me just see if I know that already for any person. Person 1, here we go, checked a total of 50,000 comments. So person 1's total is 50,000 comments. Now, person 2, it doesn't tell me the total. I have to figure it out. So person 2 worked for 200 minutes and checked 1,325 comments every 5 minutes. So I could figure out, well, how many comments per minute is that? If I take 1,325 and I divide by 5, that's going to give me the number of comments per minute. And I get 265. So person 2 checks 265 comments per minute. Well, that's not the total. We know that person 2 worked for 200 minutes, so if they did 265 comments per minute, I now have to take 265 times 200, and that will give me the total number of comments per minute, which works out to be 50. I'm sorry, not the total number of comments per minute, the total number of comments, which would be 53,000 total comments. Okay, so I'll circle that answer for person 2. Person 3 worked for 120 minutes at a rate represented by C equals 331T. Well, I'm just going to use my equation. C is going to give me the number of comments checked, so I have C equals 331. I know that T is 120 minutes. So the total number of comments checked for that person is 39,720 comments. Person 4, I also have an equation. C will give me the number of comments, and I need to know T is 150. So I'm going to put the 150 in that equation. I'm going to say 150 equals 3/800 times C. Now this is going to be a little tricky to solve because we have a fraction in there. We have to do 150 divided by 3/800ths. Okay, so let me write that over here. 150 divided by 3/800ths. I can rewrite this by doing keep it, switch it, flip it. So I'm going to be multiplying 150 times 800 and then dividing by 3. So if I do 150 times 800, I get 120 20,000. And then if I divide that by 3, that gives me 40,000. So, I'm running out of space to write. Let's see, person 4, I'm going to just draw an arrow here. Person 4 checked a total of 40,000 comments. All right, now I'm going from greatest to least. So the biggest amount was person 2. So person 2 with 53,000 comments would be first. Next biggest would be person 1 with 50,000 comments. And then we have person 4 with 40,000 comments. And then we have person 3 with 39,720 comments. The next ordering asks us to order the people from greatest to least in terms of how fast they checked the comments. So how quickly they checked the comments. What I'm looking for here is the speed at which they checked the comments. So I'm going to switch colors and use this for speed. So person 1, it doesn't tell me what the speed is, and I didn't have to figure anything out. So I'm going to have to figure this out now. So person 1 checked 50,000 comments in 210 minutes. So I can find how many comments would that be in 1 minute by doing 50,000 divided by 210. Now, I've told you guys a lot that you shouldn't round unless I tell you that it's okay. So I'm going to tell you right now that it's okay to do that here. So if I do 50,000 divided by 210, I get 238.0 something. So since it's 0.0, I'm just going to round to 238. So I'll do a little wavy equal sign. That means is about equal to 238, and that's comments per minute. So 238 comments per minute. Now for person 2, I already figured this out. It says that person 2 did 265 comments per minute. Person 3, well, we have a constant of proportionality here, and this constant of proportionality does represent comments per minute, so 331 is the rate for person 3. Now person 4, this gives a rate, but this is not the rate of comments per minute, it's the rate of minutes per comment. So it took the person 3/800ths of a minute for every comment. So if I were to reverse the equation and start with C equals, I would need to use the reciprocal of 3/800, which is 800 over 3. So this is my rate in comments per minute. So if I do 800 divided by 3, here is another opportunity to round. I'm going to tell you it's okay to round here. So 800 divided by 3 gives us 266.66666, so 0.6 repeating. We're going to round that up to 267. So I'm going to say that it's about 267 comments per minute. All right, now I'm going to put those in order, also from greatest to least. So let's see, it looks like person 3 was the fastest. Person 3 had a rate of 331. I'm going to shorten this to C for comments per minute. Okay, next in line was person 4, who was just a little bit faster than person 2. Person 4 had a rate of 267 comments per minute. Person 2 was just a little bit behind. Person 4 at 265 comments per minute. And then finally we have person 1 who did 238 comments per minute. So if you were hiring someone in terms of the total number of comments checked, you might hire person 2 because you might say, well, person 2 did the most comments out of anyone. But if you look at number 2, person 2 is only the third fastest. So it took person 2 longer to get those comments than it would have some of the other people. So you might say, well, if I'm paying by the hour, I don't think I want to pay person 2. I might pick person 3 to hire because person 3 can do it the fastest. But here's what else we don't know. Maybe these people had all day and some of them wasted a lot of time. So maybe some of them quit work early, but they could have worked longer and checked more comments. Who knows? But at any rate, the person you hire might depend on, do you want the person who checked the most comments or do you want the person who worked the fastest? All right, since this lesson is kind of lengthy already, we're going to skip the "Are you ready for more?" And we're going to take a look at the lesson summary. Within the lesson summary, I'm actually giving you some problems to solve because these problems are actually a little easier than the problems that we did, and all of the information you need is given to you. So I just want to remind you of this statement. Whenever we have a situation involving constant rates, we are likely to have a proportional relationship between quantities of interest. So basically, when we have constant rates, like someone's traveling at the same rate, or checking comments at the same rate, or flying at the same rate, then we're likely to see a proportional relationship, and we can write a proportional relationship equation. Okay, I would like you to pause the video, and I want you to write an equation for each situation and solve. Now, I don't tell you what to use for number 2 for your variables, so you're going to have to decide. Whatever you use, make sure you write what it stands for so that I know what your equation means. Okay, pause the video and give them a try. All right. Hopefully you did this on your own. So let's take a look at the first one. 2 birds are each flying at a constant speed. The first bird's flight can be represented by the equation d equals 25d. What do you think this represents? D probably would be distance and t would be time. The second bird traveled 96 miles in 3 hours. Which bird is flying at a faster rate? Well, the first bird's flight, we have the constant and proportionality right here in the equation. So the first bird, let's call him bird 1. Bird 1 was flying at a rate of 25 miles per hour. Bird 2 we have to figure out. Bird 2 traveled 96 miles in 3 hours, so we need to take 96 divided by 3 to find out how much that is in 1 hour. And when we do 96 divided by 3, we get 32. So bird 2 traveled at 32 miles per hour. It's asking us which bird is flying at a faster rate. Well, definitely bird 2. Bird 2 can go more miles per hour than bird 1. Okay, number 2 says, after 4 minutes, the water in the bathtub was 3 inches high. If the bathtub is 13 inches high, how long will it take until the water overflows? This is a very real question. If any of you have ever overflowed a bathtub, this could be a very useful thing to actually time yourself and figure out at home. So I'm going to need to find a rate maybe. Maybe I want to know how long it takes, or let's do it this way. How many inches are filling up in 1 minute? So how many inches per minute? You could also think, how many minutes does it take for 1 inch? And you could approach the problem that way. But I'm going to do it this way. I'm going to find how many inches per minute. So if I do 3 divided by 4, that just gives me 0.4, or we'll just say 0.75. I think I just said 0.4. I meant 3/4. It's just, you could say it's just 3/4, or you can do 3 divided by 4, and you'll get 0.75. So it's 0.75 inches per minute. When you use a diagonal line like this, it's another way of saying per. So 0.75 or 75 hundredths of an inch per minute. Now, if the bathtub is 13 inches high, how long will it take until the water overflows? Well, let's write an equation first. So let's let W stand for the height of the water in inches. And let's let T, good old T, stand for the time in minutes. So if the rate is 0.75 inches per minute, we're going to multiply that by the time to get the height of the water in inches. So it says if the bathtub is 13 inches high, so when this number gets to 13, how long will that take? We're going to find T. So I'm going to rewrite this equation as 13 equals 0.75 T. In order to find what T is, I need to divide. So I need to take 13 divided by 0.75, and I get 17.33333. So 17.3 repeating. So it would take 17 1/3 minutes until the water would overflow. All right, this was a long video, so thank you for watching. I know writing equations can be confusing sometimes. The more that you do, the better you're going to get at it. So persevere, keep working, do all these problems that we have on Khan Academy, and you will get there. All right, thank you.